Thanks. Yeah, looking forward to all your talks. So I'll go ahead and introduce the first one. So this is a project with, and I'm sorry if I mispronounce any names. So we've got Elisa Nobrega Pasos, Lakvinder Kaur, Ninibeth Gibeli Sarmiento Herrera, and the mentor was Mohammed Mushif Karadan. And this is on understanding historical and future impacts of El Nino on climate and food production in Colombia and Indonesia. So take it away, whoever's going to do this presentation.
Okay, can I start?
Yes, we see your slides and hear you. It's all good.
Okay. Hi, everyone. My name is Elisa, and I'm here with Nini to present our work. Unfortunately, it's too late in India for Lakvinder to be here with us today. And we are the Vivace group, and our work is entitled Understanding the Historical and Future Impacts of ENSO on Climate and Coffee Production in Colombia and Indonesia. The coffee production is greatest in the coffee belt, which is between the tropics of Cancer and Capricorn. In other words, it is on the tropical area, and both of the study areas that we choose are located in this range. Colombia and Indonesia are two of the 5 countries with highest coffee production, and I highlight that in these 2 countries, the coffee production is mainly carried out by small family owner farms. On the next slide, okay, we here have Indonesia in gray, and we have also Colombia in blue, and the area in yellow, orange, I don't know, red, and purple and red are areas on the Pacific Ocean monitored by NOAA regarding the sea surface temperature anomaly. The red area is nominated as Nino 3.4, and this area where the Oceanic Nino Index, also known as ONI, is calculated to infer the ENSO events. The time series of this sea surface temperature anomaly of this area gives us the ONI, which in positive anomaly above 0.5 indicate El Nino, in negative anomaly below minus 0.5 indicate La Nina events. These events are known to impact the weather globally. El Nino, for example, causes drought in Australia, while La Nina influences the rain pattern in South America. So our goal in this study is to explore the diverse impact of ENSO events on temperature and rainfall pattern, consequently affecting the vegetation and coffee production in Colombia and in Indonesia. For this, we use dataset compilation. We use the sea surface temperature from OASST from NOAA. We also use the temperature and precipitation data from ERA5. We also use the NDVA data from Moody's, and the coffee yield production statistics were from the United States Department of Agriculture. Our data ranged from 1990 to 2023, except for the NDVA, which is just after 2000. The future scenario that we made was created based on the SESM2 model prediction for the ENSO events based on the CEMIP2 4.5 scenario. This time, this analysis ranged from 2021 to 2100. In our methodology, we collected data, calculated the anomaly, and obtained the ONI index for historical and future scenarios. After that, we calculated the SSP for 3, 6, 12, 24 months moving mean, and we also calculate the Pearson correlation and the lagged cross correlation. Okay, so next, yeah, please, thank you. Okay, next, here we have finally some results. We have here the matrix correlation for some variables for Indonesia. The variable we are showing are temperature, precipitation, NDVA, SPIs, and ONI. Negative correlations are in red, and in blue, we have the positive correlation. We observe high positive correlation between temperature and ONI index, for example, in Indonesia. So this means that when we have positive anomaly for ONI, or in other words, El Nino, the temperature tends to be higher. And when you have negative anomalies for ONI corresponding to La Nina events, the temperatures in Indonesia tends to be below the average. Precipitation and NDVA presented positive correlation with SPI, which was expected. And the SPI 12 with the 12-month moving mean presented high negative correlation with temperature and ONI, indicating an opposite pattern from the one I described before for temperature. In Colombia, on the other hand, I highlight the negative correlation between precipitation and temperature and between precipitation and ONI. Also, positive correlation between precipitation in all SSPs. Otherwise, the correlation was similar to the ones observed in Indonesia.
Continuing with results, in this slide you can see for both countries the SPI within the 12 months rolling period during one of the last strongest El Nino events on 2015. As Alicia showed before, we found higher correlations between ONI and SPI. At longer time scales, the SPI can be related to groundwater and reservoir storage, so it allows us better understanding of ENSO impacts. Negative values below -1 indicate drought, and positive values above 1 wet conditions. We observe a lagged impact of SPI concerning ONI index. For Indonesia, nearly the entire geographical expanse experienced drought conditions, except in some areas where positive SPI values are observed. In Colombia, most of the mountainous region where coffee is cultivated experiences drought, and in contrast, the southeast region of Colombia presents between normal and wet conditions based on SPI. Here you can see what happened during La Nina in 2011. Both countries experienced rainy periods with SPI above 1, associated with negative anomalies in ONI and reductions of the air temperature. In Indonesia, the SPI show between normal and wet conditions, as you can see in this map. And in Colombia, most of the region show extreme and moderated wet conditions. So now you can see the ONI index and the annual yield anomalies for both countries. It is important to keep in mind that since coffee is a perennial crop, the ENSO condition in a given month impacts production between 8 to 9 months later. For Colombia, we found a significant correlation between SPI and yield anomaly, as the purple line shows. El Nino events favor coffee production, and in contrast, La Nina events can reduce it. Previous studies for Colombia report that the impact of ENSO on coffee production varies depending on the region. During El Nino, regions with beneficial effects had been those with high rainfall above 2,000 millimeters per year and low radiation, because the increase in temperature favors flowering. In contrast, warm areas with average temperature above 21 Celsius degrees and rainfall below 1,400 millimeters per year are more likely to be negatively impacted. In Indonesia, the production of coffee tends to be adversely affected during strong occurrences of El Nino, but we didn't find a significant correlation. Variations in coffee yield may stem from the complexity of Indonesia's rainfall patterns, which are also influenced by localized factors and the impact of Indian Ocean dipole. Finally, and trying to understand the future occurrence of ENSO and its impacts, this figure showcases the CESM2 ONI projection, emphasizing extreme events associated with El Niño and La Niña. The initial 25 years notably feature intense La Niña, registering values below -1.5. This period tends to offset drought in dry regions, thereby enhancing overall agricultural productivity. In contrast, the final 3 decades exhibit an escalation in the intensity and frequency of extreme El Niño events. This change in the pattern projection would be related with more frequent droughts and the increase of the air temperature. Here, we present a summary of the identified impacts of ENSO. In general, during La Niña, rainfall increases and temperature decreases in both countries, and in consequence, SPI show wet conditions. The opposite occurs during El Niño. We didn't find a clear response for coffee yield in Indonesia, and neither for normalized vegetation index in both countries. And in Colombia, El Niño can favor coffee yield and La Niña can reduce it. Closing our presentation, we want to comment that we worked together on review of literature, analysis, and writing our micro publication. And here you can see what every one of us did. And finally, we want to say thank you for your attention and for this scholarship program. And we are open for your questions.
Great, thanks. It was a really nice talk. Do we have any questions? I guess I could start us off with the question. So you looked at the links between the coffee yield and the ENSO index, and I guess you did not find a significant correlation over Indonesia, if I remember that correctly. If you just start with the temperature and precipitation, how highly correlated is that with the coffee yield? Or was that what was on your first slide? I think there you were showing the links between precipitation and temperature and the various indices. So I guess just kind of the basic links between the climate and the coffee yields. Do you know how strong they are?
Yeah, the strongest correlation with yield was specifically with temperature, but the signal was not clear for Indonesia.
Okay.
Using the SPI index, we was we able to see more clear signal of ENSO impacts for both countries. But unfortunately, the correlation was not significant for Indonesia. That's why we didn't conclude any for this part.
Yeah, so I guess there's also just other factors that affect coffee yields beyond just temperature and precipitation. And then there's also other factors that affect temperature and precipitation beyond El Nino.
Yeah.
Yeah.
Also because we use just annual data. So you know that during the year, there are other factors influencing coffee production. So
Right.
it was a big limitation for us, the time step of yield coffee.
Yeah. Yeah, that actually relates to another question I had, which was, do you have a sense of how much extremes matter? Could you have a very extreme few days heat wave that just kind of destroys everything, which maybe you don't see in the annual mean, like you're saying, or maybe coffee's just not that sensitive and just cares about the climatological conditions. Do you have a sense of that? That's okay if you if you don't. I guess
Yeah,
it's getting into the
we-
details of how coffee works as opposed to the climate.
yeah. I don't know how to answer this, but unfortunately, we have coffee data with greater time resolution for Colombia, so we could make more conclusions about Colombia, but for Indonesia, we didn't find anything better than 1 year, so we can't make a lot of assumptions about this.
Yeah, yeah, that makes sense. I guess the farmers would know if they like have some threshold where they're like, okay, this is going to be really bad, but it's
Yeah,
just hard to
sure.
get that information.
Yeah,
Are
sure.
there any other questions? Feel free to raise your hand or you can post them in the chat. Yep, Rika.
Yeah. Thanks for the presentation. I was just interested whether there was any result that you found particularly interesting or surprising when you looked at your data, or that you didn't expect at the beginning.
I think it's a good question. I don't know what I was expecting actually, but I think we had a lot of different response between both countries, and we see a clear impact with a short time in Colombia. And when we compare to Indonesia, basically, I think this was what I was more surprised.
Okay, thank you.
And the I'm sorry, and the season too, because I didn't expect more intense and La Nina on the first 25 years on the season 2 projection, and then when we became at the end of the time series, we have a lot of El Nino with higher intensity, basically.
Yeah, thank you.
Yeah, there's a question maybe related to that in the chat from Hector. It says, good presentation. My question is if you used another type of scenario, you know, how might that change and why did you choose the SSP 245 scenario?
Okay, yes, we use it a Thai model, GSP, I think. I think we try to use all the scenarios available on Climatematch Academy, but we needed to choose one, and then we correlated. We saw which model had the best correlation with the historical period. So we calculated only for the historical period and correlated with the projections for the historical period, I'm sorry. And then we chose season 2 because it was with the higher correlation. And we choose the 4.5 because we already passed the 2.6 CO2 emission. So this one is basically the most probable scenario we are going to have in the future, if you don't change anything and don't produce more CO2.
Yeah, it's good to hear that CSM2 is the best. That's the one we developed. So. Okay, any other questions? If not, I guess we'll move on, and I'll hand it over to Douglas. So thanks again for a great presentation.
Thank you, everyone.
Thanks, Ayla and Nini and